Alright, so in this video we're going to talk about concavity. So let's start by defining L of x. So let's let L of x be a name for the tangent line to a function f of x at the point x equal a. Alright, now we're ready for our definition of concavity. So definition: a curve y equals f of x is concave up at a point a, at x equals a, if there's an interval around a where f of x is greater than L of x for all x not equal to a in the interval. Alright, let's draw a function. So here's my function, f of x. Let's look at a point. Let's look at this point over here, call that a. And we'll look at the tangent line at this point. It's L of x. And you can see that f of x is greater than L of x for all x near a. F of x is greater than L of x for all x around a. So in particular, if we pick an x over here, the output on the line is below the output on the curve. So f of x is greater than L of x. And because this is true, we say f of x is concave up here. All right, so now we're ready for the related definition, which is concave down. So concave down is the same, except for f of x is now going to be less than L of x. Let's draw a picture here. So we have a curve, we have a point of tangency here. You can see that the L of x is greater than the f of x, or f of x is less than L of x for x that's near a here. Okay, so let's do a couple examples. So we want to identify concavity at 2 points on a graph. And then we want to identify the intervals of concavity. The intervals of concavity for this function. Okay, let's draw our graph here. So our graph looks like this. 1, 2, 3, 5, 6 is the domain. So here are my 2 points A and B. Okay, so the question is the function below or above its tangent line? So at A, f of x is below its tangent line. So it's concave down here. At B, the function's above its tangent line. So it's concave up here. More broadly, at all these points before 3, we draw the tangent line. The function is going to be below its tangent line. So on the interval -infinity to 3, the function is going to be concave down. And all the points after 3 If we draw the tangent line, the function is going to be above its tangent line. So on the interval 3 to infinity, f of x is concave up. Okay, so we have a special name for the point at which it changes from concave up to concave down, or vice versa. And that point is called an inflection point. It's called an inflection point. So let me just define it here. So an inflection point is a point where a function changes concavity. And if the function is profit, if the function is profit function as a function of time, so profit over time, then the inflection point is sometimes called the point of diminishing returns. Diminishing returns. All right, let's look at another example. Call this example 2. So in this example, we want to find the inflection point for each function using their graphs. So the first function is going to be negative x times x plus 1 times x minus 1. And the second function is going to be 6 over 1 plus e to the x minus 1. Okay, so I would use some computer system or calculator to draw the graphs of these two. I will just sketch them here. So f of x, if we draw it, looks something like this. You can actually do this one by hand. It has a 0 at 0 and 1 and negative 1. And it's going to be a negative x cubed plus some lower order term, so it's going to look like this. So it's going to look something like that. And the place where it changes from concave up to concave down is right here. So the inflection point is at x equals 0, or you could say it's the point 0, 0. If we draw the second function, again using a computer or calculator, this is g of x. This one's a little harder to see where it switches. So it's concave down for this first part, concave down here. And it's concave up for this second part right here, concave up here. So the inflection point is going to be that point right in the middle. That's the point 1, 3. Let's move that g of x out of the way. So the inflection point is at x equals 1, or you could say it's the point 1, 3. All right, I hope you found this video useful.